What genetic advantages do elite sprinters have? Imagine running at top speed and feeling like your body is perfectly tuned for that burst of power. Some athletes seem to have a secret weapon inside them that helps them reach those incredible speeds. Well, it turns out that certain genetic traits give some sprinters an extra edge. These traits influence how their muscles are built, how they use energy, and even their body shape. While training and technique are super important, genetics can give athletes a small but meaningful boost in their performance. One of the most studied genes in sprinting is called actin 3, often called the sprint gene. This gene produces a protein called alpha-actinin 3, which is found in fast-twitch muscle fibers. These fibers are what make muscles contract quickly and with a lot of force. Nearly all elite sprinters have at least one copy of the R allele of this gene. If a person does not have this allele, their muscles might not generate explosive power as easily. Another gene that plays a role is called the ACE gene. Variants of this gene can influence how muscles work and how efficiently the heart and blood vessels deliver oxygen during intense activity. The I and D variants of the ACE gene affect blood flow and energy use. Certain combinations are more common among top sprinters and can help improve performance, especially in short, fast races. Beyond these two genes, scientists have found over a dozen other genetic markers linked to sprinting ability. These genes affect how muscles grow, how energy is produced, and how nerves send signals to muscles. All of these factors contribute to how quickly an athlete can accelerate and how powerful their movements are. Genetics also influence body shape. For example, Usain Bolt is very tall for a sprinter, standing at 6 feet 5 inches. Longer limbs can make stride length bigger, which is an advantage once at top speed. But taller athletes often find it harder to start quickly because of their longer limbs. Bolt's ability to accelerate fast despite his height is partly due to his genetic makeup and his training. Muscle biopsies of elite sprinters show they have a high percentage of fast-twitch fibers. These fibers are perfect for short, explosive efforts but tire quickly. Genetics determine how many of these fibers a person has, which can give them an advantage in sprinting. At the highest level of competition, even tiny genetic differences can be the difference between setting a world record and just missing it. Studies suggest that genes like actin 3 and ACE might explain about 1 to 1.5% of the variation in sprint times among top athletes. That small edge can be the difference of a few hundredths of a second, which is enough to break a record. But it's important to remember that no single gene makes someone a champion. Sprinting success depends on many genes working together, plus years of training, good nutrition, and mental focus. Genetic testing can show potential, but it doesn't predict who will break records. It just shows who might have a natural head start. Most genetic advantages are subtle and only matter at the elite level. For most people, training and technique matter much more. Even among the fastest sprinters, the combination of genetics and hard work is what pushes the limits of human speed and helps set new records. So, in the end, it's a mix of biology and effort that creates those incredible sprinting feats.